It's over there never works as a direction. 2 streets down, 1 street left does. In this video, we'll pin down the exact location of any point using just 2 numbers and find the distance between 2 points without ever touching a ruler. Think about graph paper or the grid lines on a map. That's a coordinate system, a structured framework that lets us describe the exact location of a point using numbers instead of vague words like over there. To build one in 2 dimensions, we take 2 number lines and place them perpendicular to each other, one flat, one standing up. The flat one is called the x-axis. The standing one is called the y-axis. The exact point where they cross is called the origin, and its coordinates are always 0, 0, 0. This whole flat surface, with both axes drawn on it, is called the Cartesian plane, or just the coordinate plane. Now here's the rule for reading any point's address. Every point gets exactly 2 numbers, written as x, y. The first number, x, tells you how far to move left or right from the origin, measured along the x-axis. The second number, y, tells you how far to move up or down, measured along the y-axis. Move right or up from the origin, and the number is positive. Move left or down, and it's negative. So a point like 4.50 sits exactly on the x-axis, 4.5 units to the right of the origin. The 0, as the second number tells you, it hasn't moved up or down at all. A point like 0, 4 sits on the y-axis, 4 units straight up. Once a point moves off both axes, it lands in one of 4 regions called quadrants, and the axes are exactly what divide the plane into these 4. They're numbered going counterclockwise starting from the top right. In quadrant 1, both x and y are positive, top right. In quadrant 2, x is negative but y is positive, top left. In quadrant 3, both are negative, bottom left. In quadrant 4, x is positive, but y is negative, bottom right. So a point like 3, 5, with a positive x and a negative y, must be in quadrant 4. And a point like 5, 3, negative x, positive y, lands in quadrant 2. Get the sign pattern right, and you always know the quadrant without even plotting it. Here's a genuinely useful skill. Finding the distance between any 2 points, even if the line joining them is tilted, not lying flat along an axis. The trick is to build a right-angled triangle using the 2 points as the 2 ends of the slanted side, called the hypotenuse. Say we have point A at 3, 4, and point D at 7, 1. Draw a horizontal line from one and a vertical line from the other. They meet at a corner point, and now you've got a right triangle sitting right there on the grid. The horizontal leg of that triangle is just the difference in the x-coordinates. 7 minus 3 is 4 units. The vertical leg is the difference in the y-coordinates. 4 minus 1 is 3 units. Now here's where it clicks. This is exactly the Pythagoras setup you already know. The distance AD, the slanted side, is the square root of 4 squared plus 3 squared, which is the square root of 16 plus 9, which is the square root of 25. So AD is exactly 5 units. That's the whole method. Subtract the x's, subtract the y's, square both, add them, and take the square root. Generalize that, and you get the distance formula. The distance between any 2 points, x1, y1, and x2, y2, is the square root of x2 minus x1 squared, plus y2 minus y1 squared. It doesn't matter if that subtraction gives you a negative number. You're about to square it anyway, so the sign disappears, and it works exactly the same in every quadrant, even with negative coordinates. That's the power of this one formula. It replaces a ruler completely. Quick check. The question's on screen. Pause if you like, but try it first. 10 seconds, go. Point 5, 3, has a negative x and a positive y. Negative x positive y is exactly the quadrant 2 pattern. So the answer is quadrant 2, option B. Two axes build the plane. Every point gets an XY address. The sign pattern tells you the quadrant instantly, and distance always comes down to one Pythagoras-based formula. Free notes in the description. Subscribe to Clarix for the rest of Class 9 Maths.